So on the last video we got this far with our code, and this produces our 6 circles, 1 blue and 5 black circles. There it goes, quite happily. Our little turtle is running around quite happy to itself. Now, a couple of things that we need to know. We've got the names here for the colours, blue, black, and then I can change them to other colours that I want to do. The other thing is I've got 6 circles, but they're covering a very small area. We only rotated through 10 degrees. I've got 6 circles. There are 360 degrees in a complete circle. So if I wanted to, I should subdivide that up. So what I should do is 360 divided by 6. And if I do some quick maths, 6 into 36 goes 6 times. So it's 60 degrees. So if I get each one to go through 60 degrees, then that should give me, when you run, it's going to ask me to save. I should then get, there's my first circle, much greater angle of difference here, 60 degrees rather than 10. There's the red one that I've just coloured in, and there it goes. But now I've got, it completes a full cycle of the system, so it works quite pretty. This naming is quite fun, but I then have to know the names. And there is a library of them. There they are on the side. You've got a mixture of UK and US spelling. I looked earlier, and there is grey with an A, and there is grey. There's the ones with A, and a bit further down we will come down to grey with an E. They might even be the same values. This whole list, this is a long list, so there's no way you're going to remember these names. You're going to remember some of them, but not all of them. And there are a lot of those there. The numbers down these sides reference the red, green and blue, the quantity of red, green and blue, and that's what I'd like to have a look at the moment. So if I look at this code here, instead of typing in blue, I know that the system is split into the 3 colours, red, green and blue, and that I can start these off quite happily by using the hash marker and knowing that 2 digits represent red. Well, this was blue, so I don't want any red, so I put 0 in, 2 zeros to represent no red at all. The next one is green. I had no green because it was blue, so I'm going to put that in. And I want all the blue I can have. Now, all the blue happens to be FF, and this is using something called hexadecimal. Hexadecimal is using a lot of colours, a lot of ranges of colour. And that one, first 2 digits are red, next 2 digits are green, the last 2 digits are the quantity of blue. 00 being none, FF being completely. And you can vary those, so the digits can go from 0 to 9 and then include the letters A, B, C, D, E or F. You need to explore hexadecimal, but once you've got your head around hexadecimal, this works really nicely. Black, for example, is the lack of any of those 3 colours, so I can put the hash in and there is no red, there is no green and there is no blue. And obviously red is all red, oops, no green and no blue. Now the next colours I've got are all black, so I'm going to change those now, and I'm going to tell it to, well, I'm going to have a little bit of red, so I'm going to go for 4E. There's some red there, a bit of green, so let's go for quite a bit of green, so let's go for A6, and then let's go for a splash of blue. 5 would be nice. And then I have no idea what these colours are going to come out on. They could be absolutely horrendous. But let's try this one as well. So in this case, we went for 4E. Now, the first digit is low. Similar to 23 is very low and 98 is very high. That first digit, the 2 or the 9, gives us some indication of the magnitude of the value. 4E tells me it's quite low. The higher up that number is, just like our normal numbers, the closer to 9, the higher. And if it's got a letter at the front, then it's very high. So A, B, C, D, E, F. So if I go for a B at the front and then B and a 1, then that's high up in the colour chart, but it's low down in the B category, so you can get your head around that one. I'm not going to have any green in this one, and I'll have all of the blue, so this is going to be a shade of blue. And then on this one, we'll keep it relatively simple. We'll have a 4, 4, 5, 5 and 6, 6. Let's go for that. That seems quite nice. I have no idea if it's nice. Run module, and let's see what that has done. So there's our blue. So we got blue and we got black. We expected that. There's our red, and then we come into the new colours. These mixtures of colours. Oh, and it didn't like something I did on my colour chart. So let's go back and have a look at that. And I forgot to put the hash in. And that's the thing with coding, is you can miss off one simple thing and this sea of red comes up, and you've got to look back at your code and work out what's gone wrong. Well, I missed off the hash. It had to be there because everything else appeared. So I'm going to run this again, click on OK. When it comes up, I'm going to move this to the side just so we can see the colors as they appear. So there's the black, which is this one here, and then red, and then this mixture of green, and then this one, which I thought was going to come out quite blue, and it didn't. And this one's come out of grey because it's a mixture of all three colours, nice balance between them. So I now have those colours. Why would I bother? Why don't I just use the names? Well, the names are really useful. There are hundreds of them. But actually, if I know my calculations, I know that 0, 0 to FF, the number of combinations of colour, the number of combinations of red, for example, I can have is 256. So 256 shades of red. And there are also 256 shades of green. That means that I've got 256 shades of red, and for each shade of red I've also got 256 shades of green. That means I multiply 256 by 256 and I get a large number. But there's also 256 shades of blue. So for every shade of red there is 256 shades of green, of which there are 256 shades of blue. So I now need to multiply that by 256. And that tells me that my computer can generate 16.7, rounding up 16.8 million colours. Now that list I showed you earlier, that's a lot of colours, but there are not 16.8 million colours, million names there. Now that would be ridiculous. And that's the point. I have a full range of colours. I can manipulate this and get perfect colour range if I wish to, and I can alter these, and they're also mathematically calculable. So I can always do things that calculate a new colour. I could get the computer to generate a colour that's not got a name for it. But if I use names, I'm restricted to those names. If I wanted the computer to select a name, I'd have to teach it all these names. But later on, we'll find a way of making it so it chooses its own colours, based upon simple formulae. So before we go there, we've got these colours here, and it's quite nice, but if I look at my code is doing the same thing each and every time. It's running through the same amount of code. What I would like to do is I'd like to make a change. I'm going to create a list, and that list I'm going to spell in the UK colors. I'm going to create a variable called colors, just like I created a variable called my turtle, and that's actually an instance of an object, but this is not an instance of an object. This is going to store data. Some square brackets in here, single quote, and then I'm going to put the colors in that I've just given to my object. So the first one is there. I'm going to separate these with a comma, and then I'm going to put the next one in, which again was a hash 1 2 3 4 5 6, and then I'm going to do that again, and again. Oops, forgot that. There's one of those errors. It came up in red before I'd even got anywhere with it. A655. And almost there. Whoops. Get my keyboard correct, and that will help. And last but in no way least is my shades of grey. Didn't have to do the same colours, but it's quite nice too. I've now got a variable, and that variable's got a list in it. That means that I can now use this creatively. I've now got all my colours at the top here, and that means that if I want to add new colours, I can simply do so by adding to my list. Now they're the same ones here, but I don't have to go from line to line. I've got one line where I can change a color and it will just change for the whole sheet. Now if I look at each line of code, the only thing that was different between my 6 circles is the fact that I've got the color change. Apart from the color change, I haven't got anything else. And if I could now use the color change in there, I could actually, if I could use my list of colors, I wouldn't have to repeat this. I could get the computer to repeat my code. How can I get my computer to repeat the code? Well, I'm going to use something called a loop. And that's the primary purpose of this video, to get our heads around a loop. A loop is something that runs the same code over and over and over again. Now a loop can use lots of things as its structure. It can count through numbers, or in our case it's going to count through a list for color in colors. Now, whoops, spell colors correctly and that would help. Now that was going to look very peculiar to anyone who's looking at it, but what that's saying is create a new variable called color and go through the list colors. Now take the first color and store it in the variable called color, and then run the code that comes after. And then do that again with the next one and the next one and the next one. How many times will this run? Well, how many colors I've got? I've got 6 colors. So that's going to work quite happily without any difficulty there. And what I'm going to do is press enter and notice how the system's indented. That's given a line coming in. I'm going to bring my lines of code up now. Tab that in and tab this in. So what I've got, this tabbing in most languages isn't that vitally important, but in Python it's critically important. This tells the loop that this is the code it works with. Any code that's not indented is not treated as part of the loop. So when it chooses the color, it will run these 3 lines. Now what that means is I can now use inside this area, I can now use the variable name color. And what it's going to do is take this color code at the top, this string of colors, and use each one. Why is that useful? Well, it means I don't need these lines of code. I don't need to keep repeating the same lines of code. I only have those 3 lines. Because they're identical, I just run the same lines, and what it's going to do is take the code from each one. You don't have to take my word for it. Let's just have a look at this. Just get rid of that one. Run module. Okay. There's the first circle, and there's the second, and it's going to create each one. Even though I've got fewer lines of code, I've got exactly the same result being produced. My system is producing more and more circles, and one of the really neat things that I can now do with this, just close them, stop the code from running, move there, expand this out, is that I can always add new colors. Oops, remember the single. And I've got to remember I can't go beyond, so let's go for D4, E2, and then go for very little blue. And if I now run my code, it should produce 7 circles. The only thing is the angles are going to be wrong because I've calculated it for 6 circles. But that's all right at the moment. I just want to see how that works. Ooh, there it goes. That's covered over the last one. How would I know what I'm looking for as the degree of change? What if I get my calculator back up? I take 360 degrees. I've now got 7 colors, so I divide by 7 and I'm going to get a really strange number. But let's just take it as 51 degrees. So all I've got to do then is change this once, only once, 51 degrees. If I now run this and I go through there, smaller degree of change. It's not going to be perfect because I've got an unusual number, but I am going to get all 7 circles appearing, and the degree of change is very, very small. Now I've got 7 circles, but because I've used the loop, previously I'd have had to change 51. I'd have had to copy the code down, change all of them to 51. If there were 60 circles, I'd have to change each one 60 times. I'd have to alter the degrees. Now I've only got to change it once, and what would be really cool next time is if we don't have to change that at all, we get the computer to change it based upon the length of the colours. But that's not for now.